hope this recording is working well. So, good afternoon, everyone, and good afternoon, Professor. I hope that you get well soon and can teach us like usual. And this afternoon, I would like present about meet my proposal project, and the title is about optimizing medical checkup scheduling for hospital Q. And I bring a case from National Cheng Kung University student. Okay, let's talk about the problem description. Previously, I talked about problem description in research way, and I changed the description to be like this. So the first problem is each patient need to take all examination. I mean, there are 7 examinations, so each patient need to take all of them. And the second, a patient sometimes need to wait if there is no examination room available. And the third, there is rule that each patient need go to each floor in a sequence. I will tell to you how about the floor in the next slide. And the four is there are 1 of 4 examination, 1 to 4 examination on one floor. And the last problem description is there is cost for waiting time. So in this research, we make a model to get the lowest cost as possible. The research question, I put 2. First, how do different scheduling tactic impact wait time and service quality for university student in hospital, and how mathematical model and optimization approaches such as integer programming be utilized to improve the efficiency of medical checkup lines for university student in hospital settings. Here, I want to discuss about the floor. So in National Cheng Kung University, there are 3 kind floor. The first is first floor, and the second floor, and the final stage is basement floor. Each student need go to first floor first, and then go to the second, and then go to the basement floor. Each floor have specific examination. In example, for floor 1, this floor designed for heart rate examination, blood A examination, body mass index examination, and health record examination. Each examination maybe have 2 rooms or more than 1 tools. An example, for plan A examination, there are 2 tools that can be used, so 2 patients can do plan A examination in the same time. And then after all of the first floor examination is taken, the patient can go to the second floor to take general checkup by doctor, and then go to the basement floor to take urine examination and blood examination. Okay, after we know that each floor have specific examination and the examination can take 2 patients in the same time, then we discuss about the processing time. For the first floor, the processing time for heart rate examination is about 2 minutes. For plan A is 3 minutes, and here is the minutes for general checkup by doctor, and finally for blood examination is about 2 minutes for each examination. Okay, in this research, I try to do classical method to solve scheduling. The first is I think everyone know, first in first out. So how it works, An example, there are two students in front of the gate, and the first student jump to the heart rate examination, and the second come. Yes, because of the first examination tool is used by the first guy, so the second guy waiting until the first person finish. If the first person finish, the second person get into the examination. If the first patient finish the second examination, then the second people can go to the second examination, and the same thing. So the total time for first in first out is about 19 minutes. And then I'm thinking that maybe we don't need to wait until the first guy finish, and I mean the second patient can go to the second examination. Maybe the first waiting time can be reduced as soon as possible. But when I calculate that strategy, I mean brute force strategy, unfortunately the total time is increasing. That means first in first out, or the strategy that the first guy need to wait until the second guy need to wait until the first people finish the sequence is much better than brute force technique. And then by employing integer programming, I'm trying to make a model, and here is decision variable. The decision variable is here. First is HIGK. What is that? Is a decision variable where xig equal to 1 if patient examined in examination I, room G and floor K. And what is WIGK is a processing time for I, G, and K, and RXK is a number of examination in floor K, and RIK is number of room in examination I and floor K. Okay, after we know the decision variable, we need to make a constraint so the environment can be constructed. First, each patient need to take all examination. So I want to make sure that there is a 1x in every J and K. So I create this constraint. And the second is each room can only use for one patient. So I type like this: xijk less than 1 for each gk. And then I want to make sure that the sequence in beginning slide, I show that a patient need to go first floor and then go to second floor and finally go to basement floor, right? So I want to make the sequence by formulating this constraint. So the xig plus xig minus 1 is minus rxk plus xk minus 1 is equal to 0. That means the previous steps is and the current steps is done, but I set k higher than 1 because for k equal to 0, the k minus 1 is error, so I set k higher than 1. And then the decision variable is integer, so yeah, because it's integer programming, so I set xij is part of 1 or 0. And there are two other constraints. The first is total number for examination I and floor K are limited. So I set j a xij less than rik in every I and k. And for total examination on each floor are also limited. So I set this formula. Finally, after we set the objective function and we know the decision variable, here is my purpose objective function for this kind of problem. This function is this model I'm to minimize, want to find the minus 1 of xijk multiplied by waiting time of ik. Okay, maybe it's all for my presentation. I'm looking for the question and I'm looking for the building critique. So I hope that the model for my final or for my project can get much better performance than previous one and then current one. Thank you everyone, and thank you professor, and again I hope that you can get well soon as possible, and I hope that everyone is well, because the weather is the temperature is going down. Okay, it's all for me. Thank you very much. Good night, good afternoon.